everybody. Today we will discuss the next topic of the photochemistry, that is Norrish type 1 in cyclic compound. So in the last class we have discussed the photochemistry of the cyclic photochemistry of the carbonyl compound, and we have already discussed the Norrish type 1 in a cyclic carbonyl compound. So yesterday we already point out that in Norrish type 1 the alpha cleavage will occur. So similarly in the cyclic compound also, so this is the cyclic compound for example, and in the cyclic compound also if you are irradiating with H nu, first of all the alpha cleavage will occur and to form the two radical as in the case of the Norrish type 1. This is the primary process, and after the primary process there are four different type of the secondary process, that is recombination, decarbonylation, hydrogen abstraction and ketene generation. So here first of all the decarbonylation will occur and to form a new radical. After that the radical will combine together and to form a cyclic product, or otherwise it may undergo the recombination again and we will get the initial product, initial reactant itself. So the next is the disproportionation reaction. The disproportionation reaction will occur by alpha hydrogen abstraction, and we will get an aldehyde. On the one side of the carbonyl group and get a double bond in the other side. So these are the ring expansion may occur. So these are the different type of the secondary process occurs in Norrish type 1 in cyclic carbonyl compounds. Now we are moving into the next example. See here it is a cyclic ketone. While we are irradiating with H nu, the alpha cleavage will occur and to form a new radical, free radical, and it will undergo the decarbonylation and to form a new radical. And since uh, the two radicals are formed here, it will combine together and to form a cyclic propyl ring. So next is the beta cleavage in cyclopropyl ketone. First of all, a cyclopropyl group is attached to a ketone. First of all, if you are irradiating with H nu, so alpha beta bond will occur. So here the speciality of this compound is the alpha beta bond is very weak, so we can easily break this bond by the irradiation of the light. So we will get a two radical here. See, this is the two radical I have shown by the blue dot. And after that there are two possibility, the hydrogen abstraction. The hydrogen can be abstracted in either right hand side or the left hand side. So if we do the right hand side, what will happen? We will get a, if the hydrogen is homolytically cleaved and the hydrogen radical is abstract or attached to the right hand side, that is the double bond formed, that here the two product is formed, one it is in the double bond is in the middle one, so that is the major product, or the hydrogen is in the double bond is in the terminal position, that is the minor product. So the two different type of the product is formed here. Now we are moving into the another example, that is the beta cleavage in alpha beta epoxy ketone. Here we can see that there are two beta positions are here. See here there is a one alpha position and alpha beta bonds are two alpha beta bonds are there. So here also there are two possibility. If we break the alpha beta bond in the second, alpha is in the second position and beta is in the third position, what will happen? We will get a free radical like this. And after that in the top one, after that hydrogen is homolytically cleaved and to form a conjugated ketone and a methyl group is attached to the ketone. Whereas if we break the alpha beta, the alpha position in the second and beta position in the fourth position, what will happen? The ring is expanded, and after that the hydrogen is abstracted and to form a double bond. See here, the size of the ring is increased, and there are two product is formed, and this is mainly due to the recombination of the radical. Now we are moving into another example, that is alpha beta epoxy ketone. Here we can see that the epoxide, the ketone is attached to an epoxide. See, the ketone is attached to an epoxide. So instead of the CC sigma bond alpha beta bond, here we break alpha beta bond of the carbon and oxygen and to form the two radical, and here there is no hydrogen for the hydrogen abstraction, that's why methyl group is shifted and to form a radical like this. So the newly generated radical is stabilized by the phenyl group. After that it will recombine and to form a carbonyl group and to form a carbonyl group compound. So in the final product we can see that the two carbonyl group is attached in the product. I hope that you understood the concept. Thank you.